Okay, hello Algebra students. Welcome to my YouTube channel. You all didn't know I had one because I hadn't done this yet for you, and here we are. All right, what I always like to do, I like to keep it just like it normally is for you guys on a regular day, so you don't think I haven't, forgotten about you or anything. So do you know why milk is the fastest drink out there? Milk, fastest drink out there, Latasha. Because it's pasteurized before you even know it.
I don't get it.
It's pasteurized.
Pasteurized, and then cows are in a pasture. I got it.
No pasture.
No, listen.
Milk is pasteurized. Pasteurizing milk is the process that they do to get all the bacteria out before it comes to us. It's called pasteurized.
Oh.
Okay. Yes, they're in a pasture, but that's
Mine
not
is
pasteurized.
Mine
Yours
is
is
better.
Okay, but you win. I'll
Thank you.
concede. All right. So I wanted to get this out there because I'm not going to be in class next week. But I don't want you to miss out. This is our last learning target before we test. Okay. So we want to make sure we get that done. As you can see, hopefully on the board, I believe Latasha has it set up correctly. This last chapter is called 1.5, Rewriting Equations and Formulas. So what this chapter is about is there are times in our algebraic work where we need to rewrite a formula, not to solve for a numerical answer, but to get a different variable by itself than the way it started out. So we still do the same algebraic steps to arrive there. It just is a little confusing because you want it to end in a number answer and it doesn't. Okay, so get that in your heads first. You're not going to arrive in this chapter at numerical answers. You're going to arrive at rewriting it where another variable is by itself instead of the one that you started with. So let's just get right in so you can see what I'm talking about. So this little definition I'm not too stressed out about, but I'll just show you. An equation that has two or more variables is called a literal equation. To rewrite a literal equation, solve for one variable in terms of the other variable. So it gives this example. Solve the literal equation 3y plus 4x equals 9 for y. All right, I'm going to go over to the board. Oh, it's a mess I've got to write off of here. All right, yes, sophomores, it was not rigged. Sophomores are complaining still that the seniors beat them in the brain bowl. They claimed it.
I wasn't there.
I know, you skipped. Nice.
No. I had an eye appointment actually.
All right, so we have this equation, 3y plus 4x equals 9. Okay, we have two variables. That's what makes it a literal equation. And so the directions are rewrite this equation for y. And what that means is get y by itself. Okay, at the end of this, you want to have y by itself on one side of the equal sign. Not a big deal. Same rules apply as what you did before. So move everything over to the other side that's in the way of the y being by itself. When you have addition and subtraction, we do that first. So we're going to subtract 4x from both sides, and we have 3y equals 9 minus 4x. And we look here, we say, okay, what's in the way of the y being by itself? Clearly it's the 3 being multiplied, so now we divide. Now, you can do this one of two ways. And I won't count you off either way you do it. You could just do this, and that would end up being your answer. Divide everything by 3. So you have y equals 9 minus 4x over 3. So we've got y by itself, that's the goal. Now, you can do it that way, or you can do it this way. Divide by 3, and so then you divide all terms by 3. Okay? And so that again leaves you with y over here equals 9 divided by 3 is 3 minus 4/3 x. Okay? So that's the other way you could end up with your answer. I'm just curious, by the way, as I go back over here, how did the book do it? I'm going to bet they did it the second way. And they did. Okay? There's the two ways we showed it. If you left it this way at the top, I wouldn't care, or the bottom is the reduced way. Okay? All right. Rewriting a literal equation. We're going to do another one here. Solve the literal equation y equals 3x plus 5xz for x. Slightly more complex, just slightly. All right, so I have 3x plus 5xz. equals y. All right, so so it wants us to solve this for x. Now, what we need to do, if you notice, I have an x in this first term, and I have an x in this second term. So the first thing I need to do is to factor out that x from both terms. Take it out, pull it away from these two terms. So I do it this way. Y equals, I pull that x out, and I put parentheses. When I take the x away from this first term, that leaves me with a 3. Plus, when I take it away from this second term, it leaves me with a 5z. Okay? So now, as you can see here, that whole expression, 3 plus 5z, is attached to the x by multiplication. Our goal is to get the x by itself, so my last step is divide by 3 plus 5z. And that is your answer. X equals y over 3 plus 5z. Okay? So when they say solve the equation for x, that just means get that letter by itself. So monitoring progress. You've got these 6 problems to work on. And you should be having your whiteboards in front of you and do those problems now. So whoever my sub is at this point, I'd like you to please pause the video and give the kids probably no more than 5 minutes to work through these 6 problems. You're allowed to communicate with each other as you work it through, okay? So pause now. All right, now we're back. Let me go through them quickly. So, number 1 says 3y minus x equals 9. And we are solving these first 3, we're solving for y. So we want y to be by itself. So we move everything away from y. Get it? Y is a loner, a hermit, hates everything else, right? All right, so again, we have addition, subtraction, so we do that first. And I have 3y equals 9 plus x. I'll divide by 3. I'll do it across all terms. Y equals 3 plus x over 3. Or you could have called this 1/3 x, either way. Okay, that's the answer. And again, I know that you don't like this answer because you're like, I want it to equal something. It does, you just don't know what it is. Okay, that's number 1. Number 2. 2x minus 2y equals 5. Again, we're solving for y. We want to get y by itself. Please notice the y in this is negative. And I've told you what I'd like you to do is, the easiest way to get rid of that negative is to bring it over to the other side. So we're going to add 2y. And I'm going to get 2x equals 5 plus 2y. So now I want to get the y by itself over here. I now have it positive. That makes me happier. So now I'm going to subtract 5 from both sides. 2x minus 5 equals 2y. Now I'm just going to divide by 2 to get the y by itself. X minus 5 over 2 equals y. And you may write this as 2.5 if you choose, I don't care, or 2.5. Okay, that's number 2. Number 3, 20 equals 8x plus 4y. What I want you to show you here is there's a quick shortcut that we can cut down things rather rapidly here to make our lives a little easier. Is if you notice I've got the number 20, the number 8, and the number 4. They all have a common factor divided into all of those numbers. You see what it is? Alyssa, shh, not you. Okay, it's 4, right? Clearly 4 divides into all of those. So divide a 4 by all of those and rewrite it. So 5 equals 2x plus y. Right? I've now gotten rid of that 4 by division. Now, I want the y by itself. Just subtract 2x from both sides. And I get 5 minus 2x equals y. Done. All right. The second says, solve the little equation for x. Y equals 5x minus 4x. Now, I hope you caught how you can do this problem in literally 2 seconds. You may not have. You may have factored the x out first and then done the math. But literally, if you just look at this problem, what's 5x minus 4x? What is it, Latasha? 5x minus 4x is?
X.
ABC. No, it is x. And look at this. You're done. Okay? You solve for x. X equals y. No big deal. Easy. Now the next one, 2x plus kx. Oh, they threw another variable in there. It's so annoying. Equals m. And another. Oh, doesn't matter. We're solving for x. So like I said, when you have an x in two different terms, factor it out. So pull the x out. Put parentheses. When I pull an x out here, that leaves me with a 2. Plus, when I pull the x out here, that leaves me with a k. Equals m. Now I just divide by 2 plus k. To get it away from the x, I have x equals m over 2 plus k. And we're just manipulating the data. We're not solving for anything. You're just manipulating equations. You're going to do this a lot in your future mathematical endeavors. Lastly, I have 3 plus 5x minus kx equals y. So I've got a whole mess of stuff. I've got a constant. I've got 2 terms that each have, I didn't write that correctly, I wrote a y here for some reason. Let's do that again. You guys probably already caught that. I've got 2 terms that have the letter x and then I have a y on the other side. It's like, okay, I need to factor, but this 3 is confusing me. Well, you know what? Let's get the 3 out of the way. We want it away from the x anyway, so let's subtract that first. 5x minus kx equals y minus 3. Now I have 2 terms with the variable in it. I can factor the variable out, put the parentheses. 5 minus k equals y minus 3. The last thing is to divide by this. And there's your answer. X equals y minus 3 over 5 minus k. Wholly unsatisfying. I'm sure you're hating this, but at least we wrote it correctly. Now we can solve. Okay. Let's move along. Let's get loud. All right, rewriting and using formulas for area. A formula shows how one variable is related to one or more other variables. A formula is a type of literal equation. You guys have seen formulas all over the place. The formula they want to highlight right now is what's surface area of a rectangular prism, a box, if you will. There's our box. Okay? So they're having us work with the surface area of a rectangular prism. What that means is the surface area is how much space on each one of the 6 faces of this box. There's one big one in the front, 2 here, 3 in the back, 4 on the left side, 5 underneath, and 6 on top. What is the area of all of those? And here's what that formula looks like. Surface area of a rectangular prism, 2 times the length times width, plus 2 times the length times height, plus 2 times the width times height. So it's asking us to solve the formula for the length L. Okay, we want to get the L by itself in that formula. And the reason this could happen is you may have a problem where you know the surface area, you know the width, you know the height, and you're trying to calculate what is the length of that particular thing, right? So I'm going to come back over here again. I'll rewrite it. S equals 2LW plus 2LH plus 2WH. And we're solving for L by itself. I've got 3 terms on this side. 2 of them have the L. So before I can factor it out, I need to move the other one away. So I'm just going to subtract. So I have S minus 2WH equals 2LW plus 2LH. Okay? All I've done is move the one without the L over to the other side. Now we're on this side. We have 2 terms that have the letter L. We're ready to factor. S minus 2WH equals, take an L out. Write your parentheses. When I take an L out of this, it leaves me with 2W. When When I take an L out of this, it leaves me with 2H. Now the last thing I do is divide to get the L by itself. Okay. And we have arrived at our answer. An ugly answer, I know, an ugly answer, but it is useful if you're working with these formulas. All right. Using a formula for area. You own a rectangular lot that is 500 feet deep. That has an area of 100,000 square feet. To pay for a new water system, you are assessed $5.50 per foot of lot frontage. Find the frontage of your lot and how much are you assessed for the new water system. Now, this is going to sound confusing because you're dealing with terms that you're probably not familiar with. Okay? A lot is what you call the piece of land that buildings are built on. Okay? Each of you, wherever you live, no matter if it's an apartment or a house, live on a lot. It is what they call an area, a piece of land that you live on, right? So this particular lot, it tells us in the problem, is rectangular. Okay? So draw your rectangle. Doesn't matter what it looks like. I'm just drawing a rectangle. Okay? We're dealing with area. So you need to recall, you've had this before my class, the formula for area of a rectangle. What is it? That's right. It's length times width. Okay? Well, what they gave us here is, they said that the lot is 500 feet deep. So that side is 500. And they said the area inside is 100,000. So the problem said you are assessed $5.50 per foot of lot frontage. Find the frontage of your lot. What they mean by frontage is this. On this piece of land, okay, remember we're seeing it from above. We're seeing it from Google Earth, right? Probably you have a sidewalk that goes this across the front of this, where people walk. Hey, I'm walking. All right? This is called the frontage. Whatever piece of your property comes across where public access is at, that's the frontage. In your problem, it's going to be your width. This is your length. This is your width, what they're calling frontage. So that's what we're trying to solve for. We know our area, it's 100,000. We know our length, it's 500. We want to solve for width. So what we want to do to help you know what to do is rewrite this formula solving for W, getting W by itself. So as you can see here, the L is in the way, so we're going to divide by L on both sides. And I'm going to have W equals area divided by length, which in this particular problem is 100,000 divided by 500. That's going to be our width. Now, quick little math hint. When you're dividing by numbers that have lots of zeros, go to the smallest one, take out the 2 zeros, go to the largest one, and also take out the last 2 zeros. And now I have 1,000 divided by 5. That's a more workable number. That equals 200. So my width of my piece of land is 200 feet. Now the problem says we are charged $5.50 for every foot of frontage we have. Well, we have 200 feet of frontage, so to figure out what they're going to charge us, we take that $5.50 and multiply it by the number of feet that we have. Okay, and that is, and then 1,000 and 1,000, 0, 0, 0, 0, 1, 1 with 2 decimals. They're charging us $1,100, okay, to put water on our land. Dang government, ripping you off. The government. How do you feel about the government, Latasha?
No comment.
No comment, that's probably wise. Probably wise. We'll talk about the government at another point in our future. Latasha is a diehard Republican. Okay, so.
Don't you ever say that again. Oh my God.
I knew I could get you to talk if I
Don't
said
you
that.
ever say that
Oh,
again.
I retract that statement so much.
Thank you.
She's a libertarian. Okay,
We're not gonna talk about my political status.
so here is this is your progress to work for here. These are 2 rewrites. So again, in my instructor covered for me today, this is the point here for, in just a moment, you're gonna pause the tape again for them to work through these problems, okay? So you've got number 7, the area of a triangle, you're solving for h, and in number 8, you have the surface area of a cone, and you're solving for the length. So, go ahead and pause at this point, and guys, get out your boards, talk with each other and work this out, and then we'll come back and fix it. And we're back. All right, so for number 7, please don't let go of this formula. You're going to see it a lot, 1/2 base times height. Okay? It asks to solve for the height. We want to get the h by itself. Well, the first thing I would probably do is I'd probably divide by the base. So a over b equals 1/2 height. And clearly you should see next, I'm just going to multiply by 2 on both sides. I have 2a over b equals 9. And that's the end. That's the answer. Okay. Then, surface area of a cone, S equals pi r squared plus pi r L. And we're solving for L. Okay? So with this one, what I would do, thinking how I want to do this. Oh, okay, so I've got 2 different terms, only one has L in it. So I gotta move the other term out of the way first, because it's addition. So I'm gonna subtract by pi r squared on both sides. And I have S minus pi r squared equals pi r L. Now I'm gonna divide by pi r. Okay, and I have that as my answer. L equals S minus pi r squared divided by pi r. You cannot cross these out because this is attached to the S by this subtraction. So do not cancel those out. They have to be by themselves in order to do that, and they are not. And so please do not do that. Yeah. Okay. Just do a little quick mental double check. See what else I want to do here. Okay, almost there. So now we're just looking at some other common formulas that you've seen or will see. All right, and so what you see here, 3 different common formulas that you're going to need to know, right? You've got the temperature conversion formula, which I've always hated. It's so complex. Can't we just switch to Celsius and be done with it, people? Please. Okay? But we're not. So this is how you convert from Fahrenheit to Celsius. You have Celsius equals 5/9 times the temperature in Fahrenheit subtracting 32, right? Simple interest. How you calculate the amount of interest you earn at a bank on your money. Interest, I, equals P, your principal, your initial amount you put in the bank, times by the rate, times by the time in years. Okay? And then the distance formula we already talked about, the dirt formula, distance equals rate times time. Okay? So, rewriting these formulas, I'm just going to walk it through. I don't feel like writing on the board right now. I think I've exhausted my desire to write. So they want us to solve it for F. In other words, if you knew the temperature in Celsius, how do you convert it back to Fahrenheit? Well, to get that, you need to rewrite this formula. So as you can see, the first thing they did here is they multiplied both sides by the reciprocal, 9/5. Right? And that crosses that out, and you see below what that becomes. Erase that. So you multiply by the reciprocal first, you get 9/5 C equals F minus 32. And then again, if we want the F by itself, clearly the last thing we have to do is add 32 to both sides, which is what we did here. And you have your final answer. The temperature in Fahrenheit equals 9/5 times the Celsius temperature, and then add 32 on at the end. Okay? Using the formula for temperature, and they gave an example. Which has the greater surface temperature, Mercury or Venus, and they gave you the two temperatures. Okay, and then they had you work it out, and you found out that the greatest temperature, when one is in Celsius and one is in Fahrenheit, we can see here that when you converted the Mercury to Fahrenheit, it's 800.6 degrees. Which, if you all were paying attention at Brain Bowl last week, when it was asked which is the hottest planet, I thought it was Mercury. What's the Brain Bowl people got it right is actually Venus. Venus is hotter, 864 degrees temperature. That sounds like a Florida summer to me. All right. Monitoring in progress. A fever is generally considered to be a body temperature greater than 100 degrees. Your friend has a temperature of 100 degrees Fahrenheit, sorry. Your friend has a temperature of 37 degrees Celsius. Does your friend have a fever? Okay, so you need to convert one or the other. One or the other over to the other temperature, right? So go ahead and pause at this time, please, instructor, and the students, please work out this problem on your boards. And we're back. I'm going to take the 37 degrees and put it into that formula. Okay? I need a calculator. You all would need a calculator for this, and that's fine. I won't give you a problem like this on your quizzes or tests unless I allow you to use a calculator. But with this type of fraction, you definitely need a calculator. Erase. So, rewritten, the Fahrenheit temperature is 9/5 C plus 32. In this example, C was 37 plus 32. So I take 9/5 times 37. 9 divided by 5 times by 37 equals, we're going to round to the nearest whole number, equals 67 plus 32 equals 99 degrees. So by definition it said if the temperature was 100 or more, the child had a fever. Clearly 99 is less than 100. There's no fever. Okay? All right. Last thing. Using the formula for simple interest. This is going to be important later in your life. Maybe sooner rather than later as you guys start working jobs and making money, or as you get gifts from your family, you may put it into a bank account to start saving money. You deposit $5,000. Wow, you must be rich like the Ovesen family. You deposit $5,000 into an account that earns simple interest. After 6 months, the account earns $162.50. What is the annual interest rate? So, again, this is the interest formula rate. Okay, and so you have interest equals principal times rate times time. In this problem, we're asked to solve for the rate, which is R. So we have to rewrite the formula to look like that. Okay? Dividing by P and by T to get R by itself. So the rate is the interest earned divided by the principal times the time. So here's what that looks like. We were told in the problem we earned $162.50. At the bottom, the P, the principal, we started with was $5,000 we invested, and this was over 6 months. Remember, the time is in terms of years. So 6 months, as you all should know, equates to 1/2 of a year. That's why it's 0.5. Calculate that out, you get this answer, 0.065 equals R. R you express in terms of percentages, and so you all should know to go from decimals to percent. You move the decimal over 2 places. 1, 2, and it's 6.5%. That's your rate of return. Not shabby. No bank is paying you 6.5% interest, that I can tell you. That's a fantasy land. Right now, if you stick your money in the bank, you're maybe going to get 0.5% interest. Okay? It's not worth keeping it in there unless you're afraid it's going to get lost. All right, I'm not going to worry about the distance formula problem because we've done those. Okay, you can do that down here. Last things to do, and then we'll finish up this lesson. How much, you got numbers 10 and 11. So again, instructor, at this point, please pause. Pause. And let them work these problems out. All right, and we're back. You're probably going to have to use you did use a calculator. I should have told you that ahead of time. To use a calculator to solve these. Teacher, they could have been using their phones for that because they probably don't have a calculator on them because I banned calculators. So anyway, how much money must you deposit in a simple interest account to earn $500 in interest in 5 years at 4% annual? So our formula again is interest equals principal times rate times time. IPRT, whatever you want to call it. Well, they're asking us how much money must you deposit. That's your principal, your P, how much money you put in to start with. So to get that, we got to get P by itself. We divide by our T on both sides. So I over RT equals the principal. So my interest earned was $500. Divide by the rate, which is 4% is 0.04 times by time, which was 5 years. So you're going to want to do this bottom thing first. 0.04 times by 5 equals 0.2. So 500 divided by 0.2. And that is $2,500. Okay? So what that means is this. If you put $2,500 into a bank and it earns 4% interest and you leave it there for 5 years, you'll earn $500. It's more complex than that, but that's called a simple interest formula. Last thing. A truck driver averages 60 miles per hour while driving freight and 45 miles per hour on the return trip. The total driving time is 7 hours. How long does each trip take? Okay? So we have our formula, dirt. Distance equals rate times time.
The battery.
I'll finish.
Okay.
Okay, so here we're asking how long does it take? We're wanting to solve for time. So we need to divide by R. We get time equals distance over rate. So for the first one, 60 miles per hour. Wait, I did it wrong. Wait a second, what am I doing? And you know what? We'll talk about this when I get back. My battery's about to die. Your class is probably already past your class anyway, and this is going to be more than enough for what I want for you for this section. Okay, so now you have homework to complete. So go ahead and stop the video at this point. Asta, see you next week.